cosine kind of looks like this. Okay, so there's kind of what cosine looks like, and it extends both directions. Okay, and starts at the origin at its highest point. After one quadrant goes to 0. After 2 quadrants goes to its minimum. After 3 quadrants goes to negative, or back to 0, sorry. And then 4th quadrant back to its maximums, come all the way around. So this is the graph of y equals cosine of x. However, this is also the graph of sine. And let me show you why. So let's ignore the coordinate system here for a second. Where does sine start? At its midline. So I'm just going to go someplace in here until I find the graph starting at the midline. And I see that if I start right here, that would be sine starting at its midline, except this graph does not start at the origin. So if I wanted to think of this as sine, I'd have to make an adjustment to sine. It wouldn't just be x anymore. I would have to shift the graph left or right. In this case, I'd have to move the graph. Sine would normally be right here. And so I need to shift the graph to the left. And this would be pi over 2 on the coordinate system if I haven't changed the coordinates at all. So that means that this would be x plus, because horizontal lies to pi over 2. So it turns out that this graph is y equals sine of x, but this graph is not just cosine of x, it's also sine of x plus pi over 2. Basically shifting this sine graph to the left, pi over 2, and then now I have a sine graph that's been shifted to the left, and we'll trace it exactly. So let's just take some random graph. I'm going to take a graph that starts here and goes up to here, comes back down to here, back up to here, to here, to here, to here, and to here. And this graph does not start at the origin, correct? So this graph is not just a sine or cosine graph with no shift. I can use either sine or cosine, but it looks closest to sine to me because here's the midline, and it's kind of starting there. And then the graph continues out this way. So this point right here tells me that the graph has been shifted over to the right from the origin. And that distance right there, if I think about what these marks mean, this is pi over 2, this would be pi over 6. So it's moved right pi over 6. The period, if I look at the period, the distance that I go between one full period starts here and ends here because I hit the same spot again. I go through a full up and down cycle. To make it easier to calculate though, instead of trying to figure out how long that is, I'm just going to notice that those are the same distance away from the grid line, and so I'm just going to shift it over on each end. And so the period is whatever that distance is right there, which happens to be 2 pi. So I have the period, which is 2 pi, which is the normal period. The midline is on 0, so it's not been moved up or down, but it does have a phase shift. So when I go to write this function, It is starting on the midline, if I think of it as starting here. So sine of, but it's moved to the right pi over 6. So then there's no up or down movement. There's no change to the period. There's no, oh, whoops, there is an amplitude. The amplitude here is 2. Okay, so we have 2 units for amplitude. So I need a 2 up here. So then this would be the equation of this graph. But I used the incorrect word. It is not the equation. It is an equation. I can do this with cosine. So if I started here instead, so let me change colors real quick. Let me suppose that I think of it as starting here and the graph coming down and doing this. Well, the period's not going to change. The graph shape has not changed. Amplitude has not changed. But the one thing that has changed is the phase shift. And so if I look at how far that's moved over, that's pi over 6, pi over 4, pi over 3, pi over 2, and this is 2 pi over 3. Okay. And you can look at your unit circle to count around if you need to. So that's 2 pi over 3. So it's moved to the right 2 pi over 3. And so then it would, another equation for the same graph would be 2 cosine, because it's starting at the maximum, and then x still moving to the right, so minus, and then 2 pi over 3. And so this is also an equation of the same graph. But just because, that's not the only possibility either. There are lots of possibilities. Let's suppose that I thought of it as starting here and going down, coming back up, and going back down. But it would be flipped upside down. Yes, so I could also write y equals negative 2 sine, because it's starting at the midline, x. This time it has moved to the left. And it's gone, let's see, that would be pi over 2, 2 pi over 3. So that is 5 pi over 6 right there. And so it'd be plus 5 pi over 6. This is also an equation of that graph. Let's go through and find all of them. That's a math joke. There's an infinite number. Okay, you can just keep shifting, because remember, this graph continues forever and ever and ever. Start from any point here, or any point here, or any point here, and you could get an equation. And so it would be, there's many different possibilities. There is infinite possible equations. And that's what's going to happen anytime you have a periodic function. Okay, so anytime you have periodic functions, there's an infinite number of ways to write the equation just by shifting left or right. First thing that you need to do is right away, this is not written correctly. And so first thing I'm going to do is rewrite this function. So let's say this is f of x equals 5 sine, and I need to pull this multiplier out so that in order to know the phase shift, it has to be x plus or minus a number, and that's it. So I'm going to have to pull the multiplier out, so pi over 2, and x minus, and then pi over 2 times what gives you pi? 2. So then when I factor pi over 2 out, I just need to make sure that when I distribute this back out, I get back to that. Okay, and then I have a plus 3 at the end. Now it's okay to start graphing this. So the amplitude is 5. The period, remember the normal period of any sinusoidal graph is 2 pi. And I'm going to, since this is lying to me, anything inside the function sine lies to me. So instead of multiplying by pi over 2, it's going to divide the period by pi over 2. Do a copy dot flip. That's going to cancel, and so the period would be 4. Phase shift. Now that I've written it correctly, all I have to do is look at this number, and it's gone right, because once again it lies to me. So it looks like a -2, but horizontal lies. So it goes right 2, and then the vertical shift is up 3. Things outside the function don't lie. So then I've moved up 3. This is a sine graph, which means it starts at its midline. So I'm going to grab this midline point, move it up to 3. That's the midline. And it is sine, so it starts at the origin. And amplitude is 5, which means since there's no negative up here, it's not flipped. So I'm going to go up 5. So 1, 2, 3, 4, 5. So there's my amplitude of 5. Period is 4. But we talked about yesterday that when you know the period, you also can figure out what 1 quadrant worth of that period is by just dividing it into 4 parts. So if I take 4 divided by 4, because there's 4 quadrants in a unit circle, I get 1, which means this point right here should happen after 1 unit. Excuse me. Almost had to cough there. All right, so that means if I put this point at 1, that would be the first quadrant, so going up to sine's maximum. Second quadrant, going back to the 0 to the x-axis. Third quadrant, fourth quadrant, and when I get to here, notice that I am back where I started, and I am at 4, which is the overall period of the graph. So that is a trick that I use. I always divide the period up into 4 parts, and that helps me know where all of the maxes and mins and zeros will be. So that's just a habit I have. Every time I graph trig functions, I take whatever the period is and divide it by 4. Don't actually do that right there though. But I divide it into 4 parts so that I can find out what a quadrant is worth of the graph. So let's just double check my work. So 5, amplitude is 5, up 3, phase shift of 2. Uh-oh. So I completely forgot about that. So I'm going to move these points 2, right 2. Now I am right 2. There's my starting point. I have the correct period still. So if I count from here until I get back to where I started with a full up and down cycle here, I end up at 6. So from 2 to 6 is still 4. So the period's still 4. Amplitude's the same. So now it should be right. If I had checked it before, it would have been wrong. But I should have it right now. Okay? So to do a problem like this, notice that they've asked you to write it in this form. But that's not the way I am going to write it to start out with. I'll change it to that, but I'm not going to start there. I'm going to start by writing it as this. So I'm gonna start here, this format, and then I'll just rearrange it to this. Okay. And I could put this as a plus if I wanted to, but the reason I put a minus is because remember that phase shift will always be the opposite of what it looks like on the graph. So I'm going to go through and just find all the parts. So I'll start with amplitude, then I'll find the period, I'll find the phase shift, and then I'll find the vertical shift. Oops, vertical shift. And I'm just going to go through each part. So if I look at the points here, they give us a maximum and a minimum. And it's important to remember that amplitude is not the difference between the max and the min. It's the difference between the midline and the max or the min. And so it's only half of that. But if I look at the difference between these, -4 minus -5, and then divide that by 2, that would be the amplitude. So if I find the difference between this high and low point and then cut it in half, that's going to be the amplitude. And so this is really going to change to plus. So it'd be what, 1 unit? Yep, 1 unit there. And half of that would be 1/2. So the amplitude is 1/2. The period, well, they give me max and min. If I came back down to here, that would be my full period. Okay, so if I came back down to here, that'd be a full period. So I really need to, whatever the difference between these x values is, I need to double that. So from here to here is only half of a period. And so I have, let's see, -1 to 3.5. So I'll take 3.5 minus -1, find the difference between those. And so that's what? 4.5, because that changes to plus. Okay, so then 4.5, but then I have to double that, so times 2, and so it would be 9. So if I look at the graph, I can probably tell this. That looks like it's at -1, and this is at 8, so yeah, that's 9. And then phase shift, well, it kind of depends what I choose to do with the amplitude. If I want to start, if I don't want it flipped, then this is where I want to start. And that means I would have phase shifted over 3.5. So right 3.5. But I also could have gone the other way. And if I go backwards, well, I would use this one actually and flip it upside down. So if I flipped it upside down, I would go back 1, so left 1. But I'm going to go ahead and stick with this right 3.5. But you could do either one. So the other is left. This is an alternative. Left 1 is the other alternative, but it would be flipped. And then the vertical shift, that looks like halfway between -4 and -5. So it's down -4.5, or down 4.5, sorry. If I start here, that's a cosine graph starting at its maximum, okay? But if I start here, that's a cosine graph starting at its minimum, so it would have to be flipped. Phase shift determines whether it's been flipped or not. You have to flip this graph to get it to start down here. Cosine doesn't naturally start at the bottom. Cosine would start up here. So if I didn't flip it and I just moved left 1, the graph would look like this. So now that I have all this information, it's time to start putting it together. I think, personally, I'm going to do the flipped one because it requires the least motion. Plus, it'll just show you what happens when you flip it. But you could do either one. So if I wrote this out now, and I flip it upside down, the amplitude is 1/2, so it'd be negative 1/2 cosine. The period is 9, but that's not the number that goes here. Remember that the normal period is 2 pi. So you have to figure out what number would you put in here so that when you took 2 pi divided by that number, you would get 9. Now, if I rearrange this, I can flip both sides upside down. So b over 2 pi equals 1 over 9. That's one way to do it. So then this would be 2 pi over 9. And then phase shift, x. And they want, I moved it this way, so that would be left, so plus 1. And part of the reason I moved it left is because I saw this plus sign here. And I want to make sure I'm not going to get it wrong just because I put a minus sign in there. And then vertical shift down 4.5, so minus 4.5. But this is not the form they wanted in. They wanted in this form, so negative 1/2 cosine. I need to distribute that. Oh, I've got a spider chasing me. 2 pi over 9 x, so 2 pi over 9 x plus 2 pi over 9, and then minus 4.5. So that would be the format they want. And it wants me to give an exact expression. So I'm going to start by putting a minus, or wait, maybe I have to put a negative sign. Yeah, that doesn't matter. And then 1/2. And then cosine, and then parentheses. So I need a fraction. 2 pi over 9 times x plus 2 pi over 9. Boy, this takes a while to enter, doesn't it?
Yeah, it does. It's also easier to figure out putting it into that form if you do just the over 1, because if you do it the 3.5, then you have to go and figure out the actual like exact form of whatever that number ends up being, which can take a while.
Huh? What?
Never mind.
Oh, I don't understand what you said.
Well, just when you go to put the, because you have to do 2 pi over 9 times whatever your shift is, whether it's like 3.5 or 1, and then you have to put it into exact form because it wants exact form. It's easier if you just do the times 1 because that's just 2 pi over 9.
Oh, absolutely. I understand now. Yes,
Yeah.
absolutely. Yes. Yeah. Yeah, there's generally we try to shift it as little as possible. So this, I mean, I didn't tell you guys this when I did it, but usually you want the shift to be as close to the origin as possible. That's kind of a convention, but it's not required by any means. You would still get it right the other way. So I think, let's see, did I copy that precisely? Looks right. So if we check that, there we go. And the biggest challenge is that, I mean, the most common mistake that in past years I've seen on tests is this whole not starting with b outside the parentheses and understanding that that has to be distributed to your phase shift to put it into this form.